Good afternoon, good evening, whatever it happens to be. We're going to get started here on a little video lesson on polynomial graphing. In order to graph polynomials, there's three important pieces we need to know: linear roots, quadratic roots, and cubic roots. We've already seen what they look like. An example of a linear root would be like x minus 3. A quadratic root would be like x minus 4 squared. And a cubic root could be x minus 2 cubed. Just examples, right? Linear, first degree, second degree quadratic, third degree cubic. All right, well, we all know what lines look like. So if I'm looking at a linear root, if I go through 3, I go straight through it. Okay, that's what a linear root looks like. A quadratic root, we know what quadratics look like, right? They're parabolas. So a quadratic root, maybe it comes down and it touches 4 and comes up in a parabolic shape. Okay, and a cubic root, again, we all know what cubics look like. So if I go to number intercept of 2, a cubic is going to come up and approach 2, but not go straight through it, and not turn around, but go through it with a little bit of a turn, you know, like a hitchy poo, if you will, right? Kind of wiggle your way through there. All right, so we have straight through, that's linear. We have tangent, right? That's called tangent when it just comes down and kisses it. A nice little touch there at the point. And here we got the hitchy poo where it wiggles its way through, right? It's got a hitchy poo. It's not straight through, but it's going through. All right, end behavior. End behavior is simply the behavior that you have at the ends of your graphs. So let's look at y equals x squared, a graph we're all familiar with. Y equals x squared. We know that looks like this. The end behavior, the way the beginning begins, is up. And the graph ends up as well. So this end behavior we say is up, up. Y equals x cubed, for instance, though, looks like this. It starts down and finishes up. So the way the ends behave is in down, up variety, right? Always left to right. Let's take y equals negative x squared. That looks like this. It begins down and it finishes down, so the ends both behave like down, down. And, you know, we can go on all day. Let's look at a negative x cubed. It looks like this. So the ends behave, whoop, that'd be an up, not a down there, right? Starts up, ends down. So this has up, down, end behavior. Let's try to generalize that. If I have an odd degree polynomial, like an x, or an x cubed, or an x to the 5th, or an x to the 7th, okay, odd degree, and it's positive, like x cubed. This is supposed to be equal sign. Look at all this stuff disappearing here. Watch this, a little magic for you. Forward and backwards, and now all that stuff has reappeared. Equal sign, equal sign. Very annoying, but it is what it is. All right, odd degree polynomial, first power, third power, fifth power, seventh power. Just like x cubed behaves, if it's positive, it's going to start down and finish up. If it's negative, it'll start up and finish down. If I have an even degree polynomial, like an x squared, or an x to the 4th, or an x to the 6th, it's going to behave just like x squared does. If it's positive, it's going to be up, up. If it's negative, it's going to be down, down. Okay, those are end behaviors. A couple things you need to know before we can start graphing. Let's begin graphing now. So let's take a factored equation already. We'll make it x minus 2, x minus 3, and x plus 4. All right, if I was to multiply all three of these linear factors out, right, they're all linear factors, I would end up with an x to the 3rd power as my leading term, which means this is a cubic. Moreover, all my x's are positive, so when I multiply them, I'm going to end up with a positive. So I have a positive cubic polynomial. So when I'm graphing this, there's my x-axis. Here's my y-axis. I have a root at 2. I have one at 3. And I have one over here at -4. All of which are linear roots. Now I also know this is a positive cubic, despite what that says. This is getting very annoying here. There we go, positive cubic. So I'm going to start down, and I know I need to finish high. Well, since they're all linear factors, I'm going to go straight through each of those roots, starting low and finishing high. Okay, so my end behavior lines up with how my roots are supposed to be attacked. The last piece we need to do is find out what the y-intercept is, and that's simple enough. We plug in 0 for x. So I get -2 times -3 times +4, which gives me +24. Okay, let's look at one that's slightly more difficult. Let's do x minus 2 squared, x minus 3 squared, and let's do x plus 4 cubed. So we're going to do the exact same roots that we just had, but they're going to be different in the sense that they're not all linear. Notice my stuff disappeared there again. Every time I touch a different button, stuff disappears. So let me bring that back real quick so I don't mess up my roots. Okay, so again we have positive, positive, and positive. So we have a positive. Now be careful, this is x squared, and x cubed. That's a 7th degree. Right, so it's positive and odd. So it's going to have the exact same end behavior as the positive cubic did, because it's also odd. Alright, so we have -4, +2, and +3. Now even though the ends of this graph look the same, all the stuff in between is different because my -4 here is a cubic root. So when I approach that, I need to wiggle my way through it. It's a little hitchy-poo. When I get to 2, it's quadratic, so I need to come down and touch 2. And likewise at 3. So that's what it looked like. Right, I got 2 little parabolas here, and I got an x cubed graph there. Alright, and same deal, we got to wrap it up and find the y-intercept here. So plug in 0, I'm going to have -2 squared, -3 squared, and 4 cubed. So we get 4 and 9 is 36 times 64. So let's do this, calculator. 36 times 64, 36 times 64, 2304 is my root, or is my intercept. Okay, it just gives a little bit more meaning to the graph if we know what that value is up there. All right, let's look at one other example. We're going to graph this problem. We know f of x is 4x to the 4th minus 24x cubed plus 35x squared plus 6x minus 9. Now I don't graph that. And I am told, I'm given a hint, x equals 3 is a double root. A double root means it's a quadratic root. Okay, in other words, it's x minus 3 squared, right? This means it came from a factor of x minus 3, and this means it came from x minus 3 squared. Okay, double root. So I can do synthetic division with 3, and I can do it twice. So there's quartic, here's my cubic, here's my quadratic, here's my linear, and here's my constant. Bring down the 4, multiply, add, multiply, add, multiply, add, multiply, add. I should have expected that because it's a root. It's a double root, so I'm going to use 3 again. Drop, multiply, add, multiply, add, multiply, add. I should have expected that because it's a double root. All right, so I'm left with x minus 3 squared. That's what we started with, and 4x squared minus 1. Well, 4x squared minus 1 factors into 2x plus 1 and 2x minus 1. So now I can sketch a graph. Some stuff disappeared here, and let me bring that back. We know x equals 3 is a double root. We also have negative 1/2 and positive 1/2. Okay, this is quadratic, double root, right? And these two are both linear. Overall, my function, if you look there, is quartic and positive. It's a positive quartic. All right, so I have a positive and even. So when I go to graph, now I'm going to go forward and backwards again to make sure stuff didn't disappear. So I have accurate information to use here. I have 3 as a double root. I have 1/2 as a linear root and negative 1/2 as a linear root. Even and positive means I'm going to start up and end up. So these guys are linear. I'm going to go straight through negative 1/2, straight through positive 1/2, and quadratic at 3. And of course, finish it up by finding our y-intercept. Plug a 0 in. And you know what? That's even easier since I had the original equation. If I plug a 0 in, I get 0, 0, 0, 0, negative 9. So I'm here at negative 9. That's all we got for graphing polynomial functions. Hope you enjoyed it.